Point-slope form is a form of a linear equation written as y minus y1 equals m times x minus x1, where x1, y1, let's go ahead and write that, is a point on the line. Wow, that looks... So x1, comma, y1, does that look any better, is a point on the line. Generally, we will be working from modified point-slope form, which is plus y1. So our y-coordinate is just obtained from this number outside of the parentheses. But we may sometimes be given point-slope form, where we are subtracting a number on the left, and we will transform that into modified point-slope form in order to graph. So if we're given an equation in point-slope form, this is my y1, I'm going to go ahead and write it in modified point-slope form so I can obtain the point and the slope. So that's a plus 1 plus 1. Y equals 3 parentheses x minus 2 plus 1. So I've transformed point-slope form into modified point-slope form, which we have been practicing, and now I can write the point and the slope from that line. So the point is right here, 2 plus 1. So since I'm subtracting 2, that's my x-coordinate, positive 2, and then my y-coordinate is just positive 1 as well. So I can go ahead and graph now from modified point-slope form. I have a point of 2, 1, and a slope of 3. Up 3, up 1, 2, 3 over 1, up 1, 2, 3 over 1, back and down. There we go. And I will now graph my line. Kind of. That looks okay. And put some arrows on it. So I transformed point-slope form into modified point-slope form in order to graph, finding the point 2, 1, and 3. It's okay if you can just right away identify from point-slope form that the opposite of this number, so 2, and the opposite of this is my y, but we may also transform into modified to do that. A great skill to have is to transform either modified or point-slope form into slope-intercept form, y equals mx plus b, which we are very familiar with so that we can check our line. So I'm going to go ahead and use the distributive property first. So negative 1/2 x, negative 1/2 times negative 4, plus 2, minus 3, and then combine like terms. Negative 1/2 x minus 1. Y equals negative 1/2 x minus 1. That, again, does not look good. So I should have first graphed this from modified point-slope form, identifying 4, negative 3 is my point, so the opposite of this, positive 4, and then negative 3. X-coordinate of 4, y-coordinate of negative 3. Slope of negative 1/2. So down 1 over 2, up 1 backwards 2, up 1 left 2, up 1 left 2. And before I draw my line, which actually makes it a little less clear on here, I'm going to check from my transformed equation, have I graphed it correctly from point-slope form, modified point-slope form? Yes, I have a y-intercept of 0, negative 1, and my slope is negative 1/2. So this is a really, really useful way to check your line. Again, to recap, we first graphed this from modified point-slope form by plotting the point 4, negative 3, and then using the slope. And then we checked our transformed equation, y equals negative 1/2 x minus 1, to make sure we did that correctly. One final skill that we may be asked to use is to, given a point and a slope, write an equation in modified point-slope form. So y equals negative 3 parentheses is the easy part. And then I need to write, so modified point-slope form was m x minus x1 plus y1. So I need to subtract my x-coordinate, minus 2, and then plus y1. So plus negative 5 or minus 5. In this case, I'll write my work over here. My slope is 2/3, and my x-coordinate is negative, so I'm writing x minus -3 plus 6. That means my final modified point slope form equation is y equals 2/3 x plus 3 plus 6. So we were subtracting -3, subtracting -3, and that gave us x plus 3. Oh, I guess I didn't need to write this. It's right here. You don't have to show this step. You can think of this as the opposite of the x-coordinate. So if it's -3, I'm going to write plus 3. If it were positive 3, I would write minus 3. And then in modified point slope form, I just obtained this number that I'm adding from my y-coordinate.